Welcome to Elasticsearch Meetup number 1, Philadelphia. So great, thanks for coming along. And I'm James Tyack. I work here at Health Market Science. We're hosting tonight. We've been using Elasticsearch for about a year in production, and we switched from Solar. Isaac, who's presenting, is going to explain a bit more about how we use it. So the meetup group's been going for just a couple of months, and this is our first meetup. We've built up some membership, but we'd really like to hear more from people about ideas for talks and venues and where we'd like to host the next one. We're aiming to host a meetup every couple of months, so if we can get people to kind of contribute ideas, that'd be great. And tonight we've got with us also, we've got Jay McDonald from Elasticsearch and a few of his colleagues as well. So I'd like to introduce him, and I think you can like to say that as well. So.
Yeah, great. Hey, so thanks everybody for coming tonight. As James said, this is the first ever Philadelphia area Elasticsearch meetup, so we're really excited. Isaac and James and Petter and others here at Health Market Science have been great in helping support the idea behind this. They came to us and said, we want to do this, and so here we are doing it. It's awesome, and obviously I want to thank these guys for stepping forward. I always make my appeal too. We need hosters, we need presenters. We're flexible on location. We're talking about maybe doing one in Center City. So if you know somebody that has some space, for 25 to 30 people, it's really what we need at this point. Let us know, get a hold of one of us, and we'd love to try to set something up. And also, if you don't have a space, but you have what you think may be an interesting story that people want to hear, we need speakers too. So you don't have to do both, but we'd love for you to do one or the other. So I want to talk a little bit about Elasticsearch, the company, the open source project, give you guys a little bit of history, just to set the stage a little bit. So Elasticsearch is an open source project that came out in 2010, and in the middle of 2012, the founders decided to launch this company to provide training and support for users as a result of pretty rapid adoption. So in late 2012, we got our first round of funding, about $10 million, venture capital funding. And then in 2013, got another $24 million. I joined the company in May of 2013, so almost a year ago. And at that point, there had been 6 million downloads of Elasticsearch, which is, to me, a staggering number for a company, a product that really has no marketing. It's users have done their own research, started playing with it, saw the real value in it, took it to work and said, hey boss, I think we can do things better utilizing this product. And so as a result, we have lots of happy customers, lots and lots and lots of happy users. So that's great. You'll see here, there's some banners for Elasticsearch, well, for Logstash and Kibana. Kibana was created by Rashid Khan, and it's a data visualization tool. And Rashid joined Elasticsearch, the company, and brought his project with him. And the marketplace had already determined that Elasticsearch combined with Logstash and combined with Kibana made a great solution together, even though these were 3 independent projects. Later in 2013, Jordan Sissel, who was the creator of Logstash, joined Elasticsearch, the company, and brought his project with him. And since they've joined, we've been hiring developers around those teams and products to continue to iterate, develop them further, etc. So, see what else I wanted to mention. So the company, Elasticsearch, the company, is about 70 employees now worldwide, very geographically dispersed across North America and Europe. We are hiring people regardless of where they live. So we want good people, and where they live is up to them. Having said that, we do have a headquarters in Amsterdam, the Netherlands, and now a U.S. headquarters which opened in January of this year, which is in Silicon Valley in a place called Los Altos, California. And Los Altos will continue to grow and become more of a hub of development. We'll be hiring more and more people there. It also is where our CFO sits, our Chief Marketing Officer, my boss who runs worldwide sales, VP of Engineering, etc. So that I just spent the last 4 days there, and it was great. I wanted to mention that there is public training classes which are held throughout the world these days, and they're held pretty regularly in New York City, about every 8 weeks, and we have another one coming up towards the end of April. Petter, who's here, that works here at Health Market Science, he attended one, was it last week? Feels like longer, but it was last week. We had a phenomenal meetup in New York, which coincided with that training. We had about 80 people at that meetup. Bloomberg spoke about their use case. ShopWiki spoke about their use case, so that was great. And that's where we want this group to get to over time. That meetup group's been going almost a year now, so as a result, more members and attendees, etc. I want to introduce Ben. Ben, if you'll just raise your hand. Ben joined Elasticsearch in January. He is one of our support engineers, so he provides support to our paying customers. So we have developers and support engineers all providing expert assistance, guidance, break-fix services, etc. To customers who feel that this is a strategic part of their infrastructure and want to do more and do better with their Elasticsearch implementations. So if you get a chance before we leave here tonight, introduce yourself to Ben and ask him lots of questions. So Isaac here from Health Market Science is going to take over now. He plans to speak for about 40 minutes. I think we're flexible, and we want this to be interactive. So if there are questions, please please raise your hand and ask.
So my name is Isaac Reext. I'll be presenting today. So about myself, developer here at HMS. I've been here for about 3 years, and I've been using Elasticsearch most of my time here. I've done a lot of the work along with Shanta to bring Elasticsearch into HMS, and we now use it in many of our products. What we do at Health Market Science, and that didn't go. So we aggregate different sources together to produce a single view of a practitioner. So we then are able to sell this data to the government, to pharmacies, to many different medical organizations. And for the government in particular, it prevents fraud, waste, and abuse, and also for some of the payer spaces. Since we're detecting fraud earlier, we are then able to save the government money and save our clients money. We also help companies to comply with the new regulations put forth by the government. So these new regulations include different types of spend. So we have different applications to help monitor spending and report that up to the government as well. And the last thing we do is we have a lot of claims data here that we aggregate together to create a key market insight into different products. So if you have a new product coming onto the market, we will tell you who you can market that to and help to save you some marketing dollars there. Our business has two main intakes. We have the very high variety of sources coming in to HMS. We have over 2,000 sources that contribute to our master file. We then take those 2,000 sources, aggregate them all together to produce different products, which I have here. So we'll have a search API. We'll take your data and line it up against HMS's data. We'll also do some bulk processing. So MDM is master data management, which pretty much means that if you hand us your data, we will combine it, merge it together, and give you a consolidated view back of your data. The other thing to mention on the previous slide is we have Expense Manager. Expense Manager will make sure that you are compliant to get government regulations in reporting how much you spend on different practitioners while you're trying to market that new product that you're bringing to the market. PRS is check for you. So you have your master file. You can check your master file against our master file to see how well it lines up. And then we will perform audits on it when it does not line up. And obviously we use big data here. We use Cassandra, Elasticsearch. We also still use Oracle for quite a few of our different products. So we are definitely a mix. Now, why did we choose Elasticsearch? The first thing was the scaling. We can add nodes to scale Elasticsearch very easily. You add a node, set the cluster ID, and you're off and running. You can scale up, you can scale down in the middle of normal operation. The second reason, should I get the right order, is high availability. Because you can bring nodes up and down on demand, it's extremely high availability. So even if a whole rack fails, Elasticsearch will make sure there's a second copy of my data in another rack to allow me to continue operating as if nothing ever happened. We've had nodes fail and you don't even notice. The next one is one of the big reasons that we came off of Solar, is the support for nested documents. So we're able to treat one document as if it's multiple documents underneath, which we've seen in Solar were not allowing us to do on their own. So we use this feature heavily at HMS. I'm going to talk a little bit about this at the end of the presentation. I have an example of how in Elasticsearch you can do it with and without nested documents and what the advantage is. Am I okay? All right. The last thing I wanted to mention is we've had a lot of people onboarding into Elasticsearch within HMS, and they've been able to ramp up very quickly. The interface is very easy. When you compare that to the interface in Solar for how you create schemas and how you propagate those schemas to different nodes, it's much easier to do in Elasticsearch. And I would say that the developer time savings is very high. Now, I wanted to talk, just briefly give an overview. Most of this presentation today is going to be hands-on, and at that point, I'd like to get interactive to find out what people want to know more about, and I can dive into more details in any particular area. But today, my main topic is going to be aggregations. I will go deeply into aggregations and show a use case. I will talk about snapshot and restore. I have an example prepared for that. And the CAT API, which makes it very easy to look at your node's health in a friendly format. The last four I'm not going to get into today, but they are new features. We have the distributed percolator, which allows you to take your percolator, which I believe used to sit on one node, and now it will sit on all of your shards to increase performance there. You have the federated search, and then circuit breakers, circuit breakers is another key feature. This is to prevent certain queries from running your cluster out of memory. So that is a very key feature in 1.0. And then the doc values. This is the most common interface I've seen for Elasticsearch. I'm not sure if everybody's seen the head tool. This is a plugin that's available for Elasticsearch. This is the tool I use most to interact with Elastic. I just wanted to start by showing that I have one node sitting on my laptop, and you can view different stats such as the information about the cluster. I am running Elastic 1.1. Can everybody see okay? I can blow this up a little bit. Is that better? Awesome. All right. So I'm running 1.110, and you have the tech here. And then these other tabs we'll see as we jump into the data. So first thing I wanted to do is I'm going to create a schema. So that. All right. So I want to walk through. So you don't have to create a schema before you load your data. You can load your data and it will infer your schema for you. Now the problem with this is you may not agree with all the data types that Elastic chooses. So in this case, based on the data set I have, I want to create the schema. I'm just going to walk through the example of the schema, and then I want to talk a little bit about the data set we're using as well. So let me go to the schema first. So we have number of shards. So a shard is how Elasticsearch breaks up its work to become more parallel. So when you issue a query, it will send the query to each of those shards. You can optimize which shards receive different queries as well. The more shards you have, the more you can scale. So if you have 5 shards and you have 1 replica, you can run on 10 nodes and it will be optimal. You can also oversubscribe, so you can have 5 shards running on a single node, and then you can scale later and add a node, and the shards will reallocate to increase your performance. So for this demo, I did 5 shards. I don't need a lot. For other situations, I might have 20, 100, however many shards I expect. It's pretty much your number of shards times your replication equals the number of boxes you can scale to. I want to talk a little bit about the analyzer. For this data set, I chose to create a custom analyzer. So I named my analyzer key. So when Elasticsearch takes the data in, it will first do a tokenization. So this tokenization will break up the different strings into pieces. So if I have first name Mary Ann, the default analyzer will break up Mary and Ann and make those each searchable tokens. Now, if you don't want that behavior, you can use what's called a keyword tokenizer. And what that does is it keeps your string together. So as you index, it will not break apart by space, by comma, by dash, or any other piece. I also have a filter in here. This is a lowercase filter. This will keep the data as lowercase. So if the data comes in mixed case, all my searches will be case insensitive and remain lowercase. Will become lowercase. So it's the first thing I want to go over. Before I get into the fields here, I want to talk a little bit about the data set. So City of Philadelphia has some open data available. So out on their GitHub, James Tyack was able to identify a good data set which would fit this demo, which is Philly Energy. So what we have here is we have different buildings and different types, and they're rolled up into categories. It then also has how much energy they're using on the end here. So we can analyze different types of buildings and how much energy they use. James was able to write a quick Ruby script to convert this into Elasticsearch's indexing format. So this is using the bulk API for loading. So in bulk, when you submit a bulk, everything is line delimited. So my first line, scroll to the top here, my first line, it has the name of the index that will be indexed into. It has the type, and you can also provide an ID here. I don't provide an ID. Elasticsearch will automatically assign an ID if I don't provide one. And then we have here the data itself is the second line. All right. All right. So back to the schema. So most of the data in here is either double or long. So I found that. Oops. So there's many data types available in Elasticsearch. So you have double, long, string, date, I believe there's a couple others too, but those are the ones that I've used so far. So, but down here towards the bottom, where's my key? Yeah. I want to highlight this one. So here, remember that key analyzer I defined at the top? So here's how you define this as a key. So the property type I wanted to treat as a single string and did not want to break that apart on spaces or other delimiters. So I declared it as a string and analyzed as a key. Also important for aggregations is many of the aggregators require either a double, a long, or a date. There have to be some sort of numeric value that can be summed when you're doing aggregations. So I declared anything I want to aggregate on as such. So I'm going to take the data. So the first thing I'm going to do is let's create the schema. So I'm just going to drop it in here, hit curl, and enter. And now if I jump back to the head tool, we'll have a little bit more information. So now I have a Philly energy schema. I have 0 documents. And I have the couple bytes it takes for the metadata. And here is my schema. Exactly what you saw, plus a couple of pieces added. So we have the replicas defaults to 1. I could have overrode that. We have the version and the UID were added. I think everything else is exactly what I specified. Oh, and the aliases. So I'm going to also add an alias. So if I jump back. So I do a put command, Philly energy. That's going to be, let me turn back to Notepad so you guys can see. So I do a put to Philly energy underscore alias and then PE for Philly energy. I don't like to type, so I usually use short aliases for most of my indexes. And if we jump back to the head tool, you now see that we have an alias PE. You can also see that we have our 5 shards. These unassigned are the replicas, because it did a default of 1 replica. They're unassigned right now because it's all sitting on my single box. Usually you would turn those off. Also, up here, we have cluster health yellow because at this point, if one node of my cluster fails, the data will be lost because I have no replicas. So the next thing I'd like to do is load some data. So to do a bulk load, I have curl-s host to localhost underscore bulk. This will then do a bulk load of that file that I just showed. The data --data binary, and I just put it in temp pe.dat. So run that. Jump back here, refresh, and I have 259 documents. I can browse those documents now, and we can see a little bit more about what was added. So we have our document ID at the top, we have our document itself, and then here you can see we have the electrical use, and we have the property type is fire station for this individual document. Any questions? All right. At this point, I'm going to jump into a few queries. So we can use a structured query, which gives you a query builder interface. But for this example, I'm going to use any request. So I'll grab the queries out of here. All right, so the first thing I want to go over is the query. All right, so I'm doing a match all query, which is going to bring back all the documents. I'm then declaring a facet that will group my query together based on, in this case, a term. So each of these is a term. I said that don't split it on spaces or dashes, so the whole thing becomes a term. And then it's sorted by number of hits. This is the format that you would submit to Elasticsearch 090 or below for a faceted query. We have our field, which is property type, and we have our size is 0, which means I won't get any documents back at the top. Facets are very useful for storefront where you want to display different categories of products and the count that match each of your searches. So that's one use case for a facet. All right, you can also do a script in a facet. I think I'll skip the script and go to the new aggregation style for faceting. So using aggregations, it becomes very similar. I still do my match all at the top, but then I say aggs to say I'm doing aggregation. I name my aggregation, and then I again use terms and the property type, and I get the count of documents by type. Exactly the same results, just I get aggregations and by type, and then I did a bucket aggregation. So this is very similar to the features of the prior versions of Elasticsearch, but this is in the new format. Where this gets more powerful is when you go into, let's say, a histogram. Let me just put it on the screen and then go over it. All right, can everybody see that? All right. Let's slide that over a little bit. All right, is that big enough for everybody? All right, awesome. All right, so at the top, again, I have aggregations. I did by year with my name, and I said it's a histogram. Now what I'm doing here is I'm saying the year built interval of 50. Inside of that aggregation, I'm then doing another aggregation, which is the property type. So this is telling me how many of each property was built in 50-year intervals. So as we go through this, we can see in 1700, there was one building built recreational. If I jump to the bottom where you get a lot more documents, you can see since the year 2000, there have been 2 recreational, 2 police stations, 1 library, and 1 prison built. So you can nest your aggregations together. You can continue nesting them. I'm not aware of a limit on the depth, but I've only done nested of 3. So this shows just one way you can do it, but I still haven't added anything together yet. So this is another dimension on top of faceting. Any questions before I move on to other aggregations? All right. Next thing I wanted to get into was average floor space. So what I have here is I have a term aggregation with property type, asking for a size 50, so that there's less than 50 types. I'm ordering descending on area. Area is my sub-aggregation. So I have aggregation area down here. Area is an average aggregation. This will take the average per property type for building area. So with that, I can say that on average, an office takes up the most square feet per building. And then second is a courthouse, and then a prison. So I'm able to analyze on average and break it down by different types. Any questions on that before we move on? All right. So then here's where we start to get into some analytics. So let me make this a little bigger. Can't see the last one there, but this is a 1, even though you can't see it. All right. So now I take the same part of the top here, query, term on property type. But now I'm going to say do descending by electricity by area. So what I can do now is I'm going to do average, but I'm going to put a script in here. What I'm going to say is take the electrical use divided by the area and return that, and then take the average per building. So what that gives me is it's saying that first I have to run it. This usually helps. So what it's saying is there's 595 units of electricity for office space, and that's the top, and then there's 425 for a courthouse, etc., and that's the electric use. So I can break down the electric use per square foot by building type. And now I know what my most inefficient building is. To put a little bit of light behind that, let me throw another one up here. So what I added to this one is at the bottom, I want to know what's my overall average. So I dropped this one in here outside of this aggregation and next to this one so that I could just see the overall average electricity use across all my buildings. So the overall is 50,000, whereas when we go back to the I'm trying to grab that corner. Alright, sorry it's in the middle, but it's 595,000 compared to only 50,000 is your overall average, which shows that this is a much higher outlier. If we scroll to the bottom, we can see that the fire station uses the least amount of electricity at 83. So we can see there's a wide variance in the electricity use because we have 50,000 average, 83 for 8,000 for fire. Yeah, 8,300 for a fire company. So it varies very widely. You can also gather more statistics than just average. There's, yeah, go ahead, Jonathan.
You finish it.
Okay, I was just going to say you can also gather more statistics. You can get you can get a stats, which just gives you all the statistics. broken down in a single query instead of doing each one individually. So there's many other different aggregations you can do, and there's many more in 1.1 that I haven't got a chance to check out yet. I know cardinality was just introduced, percentiles was just introduced, so there's many new features that I just haven't got a chance to play around with yet. It was just released. Go ahead.
Yeah. So is the aggregation happening at the shard level and getting rolled up, or like is it all getting rolled up on top and then aggregating?
I'm not sure. I haven't looked under the covers at all. Do you want to? Can you come up to the mic?
Sure. So how this works is when at the beginning when the index was created, there were 5 shards, right? Was it 5?
Yeah, 5 shards.
Yeah. So the basic overview is when you execute this query right here, it distributes that in parallel to those 5 shards, and then it takes back the result and then it collects and merges all the results back, and then whatever comes back over here is the merged result from all of those shards.
Yeah. So,
Okay, so how
say
much shard level?
if I had each shard on one separate box, right?
Sure.
Which would have been the ideal case. Unfortunately, we're running it on one box. So processing-wise, does it happen like at a shard level and then it gets rolled up?
That's correct. Yes,
Okay.
it's in parallel. So
Okay.
it executes in parallel, and then it gets pulled back, and the node that this query gets sent to, and then it gets merged up there, and then finally it gets returned.
Awesome.
So we get unique result on each shard when they distribute the search result.
So the question is, so you get a unique result on each shard.
So
We
my
distribute
question is, can the same document be present in 2 shards?
No, so when you index a document, like for example, how many documents did you index?
I
293 or something.
think it was 259.
Okay, 259 documents, right? So let's say the first document, it goes into one of those 5 shards. The second document will go into one of those 5 shards. The third will go into one of those 5 shards. So each document will only live in one of those shards.
Yeah, I
So
don't think
overall, the performance of this, if we've got, say, millions of documents, it's going to be favourable, really, really good. What kind of response time do you get
The answer
in
to
the
that,
aggregation framework?
it depends. But I think I cannot give a straight answer simply because there's many different factors that affect that. But the thing that's important for you guys is you know that you can cut your data up, and then you know that you can distribute the data out to as many nodes as you want. So in other words, you can make it perform however you want, as long as you have money and hardware.
So here, if I do just the average of electric use on all the documents, and then it spreads it out, does the average on all the nodes, and there is still one level of computation yet to be done by this node because it has to again find the average of
That's
the
correct,
averages.
yeah. So there's a merge process that happens.
Okay, so that's
Yeah.
a process again.
That's correct, yeah.
All right, yes, so the question here is, so it happens on each individual shard, so the question is, does it happen on each individual shard, and then is there a second round for merging?
This second round.
So, and the answer is yeah, there's 2 rounds. The operation happens on each shard, and then the result of that, all the shards together is then aggregated on the first box that got the initial request. So Elasticsearch just introduced a new API in 1.0, which is DevOps friendly querying to check your cluster health and get it back in the non-JSON format, which would be easier to see when you're sitting at a terminal at 2 a.m. and trying to figure out why your cluster's not running.
Never happens.
Never. So what I have here is I'm hitting localhost with a get, and I'm asking for in the nodes what the IP is. Let me just run it first. What the IP is, the port, and the heap. So and then the name. So I get my IP back, what port it's running on, the heap percentage, and the name of the node. So you can also do this with other ones, which the shard one is much more interesting here. So when I ask for cat and the shards, it's telling me what the status of all my shards are, and whether they're started, unassigned, or what my shard health is on the cluster. There's many other pieces added to the cat API. they just added a new one for but there's many other aspects that you can query your cluster health and get it back in this format. Oh, plugins was the other one they just added. Plugin support, so you can view the plugins through the CAD API. That's pretty much all I had on the CAD API. I just wanted to show it, make any DevOps in the room available that this new feature is available. Any questions on that? All right. Next thing I wanted to go into was a backup and restore example. So the first thing I want to do is I want to create my backup repository. So what I'm going to do is I'm going to say underscore snapshots. I'm going to name my backup, and I'm going to give a few parameters to describe what's there. I'm going to say it's type file system. I'm going to back up to my temp directory, not advised. And I'm going to say compression is true. So once I create that, no, it's true. I can then look to see what backups are available. So right now, I have no snapshots available for restore. Not a good state. Right? I want to always have some backups. So let's take a backup. So didn't mean to run it. So what I have here is, let's say, put my backups a new snapshot named snapshot 1, and it's going to back up the Philly energy index. Ignore unavailable is true, and then the global state is false. So this is then going to create a backup, which I can then see right here. So I can see now I have a snapshot, snapshot 1, on index Philly energy, and state is successful. With that, I'm going to simulate an outage.
So is your first command just to define the backup, and then you're referencing it in the execution?
Yeah, so the first command was to say where are my backups going to be stored. So I'm declaring the folder and where they're stored. So whenever I take a backup, the files go there. So then you can link that onto some sort of save-off process. So you can push anything that gets saved there into a NAS or something. Make sense? Mm-hmm. So now I'm going to delete my index. Curl delete Philly energy. And it's gone. To show it's gone, I'm going to go here. And it's more than just Philly energy. Oh no, I didn't create the whole one yet. Okay. Yep. So the index is gone at this point. I can then run a single command to restore. One thing I want to show here is just how fast this goes. So I know it's a small data set. I tell it to restore. I come back here, and I'm fully online. So just like that, I've deleted my index. My alias came back, all my data came back, and I'm fully back online. Any questions with backup and restore?
We have any. Go ahead.
The question I have is primarily around, so if you're losing nodes, right, let's say you lose 2 or 3 in a cluster of 5, and now your replicas start to come into the picture and they start restoring, and all of a sudden you basically run out of headroom. Would that inspire a cascading failure for the rest of the nodes because they run out of space?
So the question is, so if you run out of space on several nodes because other nodes become unavailable, then what would happen?
Yeah, you know, once they start to restore, then...
Yeah. So if you run out of disk space, it's going to, like those nodes are then going to become unavailable. So yeah, you will end up, like, eventually if you don't have enough disk space to support your index, the whole cluster would go offline, I believe.
So what's the rule of thumb in terms of, you know, storage versus headroom?
So generally, like, So we always have plenty of, like any one node could hold our entire index. I know that's not feasible for everybody. So we generally try to make sure we have at least one replica, and it all depends how many nodes you regularly lose. The more nodes you lose, the more.
Planning on it.
The what?
Nobody's ever planning on it.
No, but if you tend to lose, if you notice you're losing more nodes, then you would have more replicas, and then those replicas can take over. I don't know of any rule of thumb unless you have one for how many nodes, how much extra disk space you should have on a given node.
I would suggest have enough, in case of whatever catastrophic failure that you're expecting.
I mean, nobody's expecting a failure. It's just kind of
Well,
how it goes with the
how
business.
much can your business survive?
The big thing nowadays is resiliency. So if you're trying to make something that you want to have highly available, the idea is to plan for failure. So to plan on, I have these things available, and if the hard drive fills up, I didn't know that could happen. I didn't put an alert on that, so plan that it could happen, and then this scenario allows that to say, oh, that happened there, it goes offline. We can spin up another one and assume that nobody else that was using my service ever knew that I had a major problem like that. So Netflix, in their APIs, they use a thing called Hystrix, which is a RESTful kind of plugin to allow your web services to remain more highly available and also determine like what to do if something fails. Like, let's say I can't post to a web service anymore, you could write to disk, and then when the web service comes available, it'll then send them all back over. So high resiliency is a big thing nowadays.
Yeah, I would say definitely plan on being able to run with half your cluster. Generally, we didn't talk about it, but generally always have an odd number of masters so that you can set your min-masters. We like to split our data in our masters for better scaling. So I would say plan on half your data nodes being able to go away, and your cluster should still survive. If those nodes go offline, those shards, the backup shards or the replica shards will become primary shards, and your data won't be lost at that point. So you're going to need to do a restore at that point. The main reason for the restore is if your index goes completely corrupt, I can go back to this point, restore my data, and I'm back in business within hours. I'm not just completely, I lost all my data. It's more for your backups, take them every hour, take them every night, however often your data changes, that you could lose data in your business. I know the big thing that's being worked on right now is it's called split brain, and it's very important to set your minimum number of masters to avoid a split brain circumstance. But in that circumstance, you may have to use a restore if you ever get in that state.
So if you get a split brain scenario, does one of the splits actually shoot stuff in the head?
You have to shoot it. As far as I know, I don't.
I didn't. And what was the question?
So with the split brain, will the split brain automatically resolve itself, or do you have to kill that node?
No, so split brain is it's a catastrophic scenario. Just so that everybody know what split brain is. Okay, just to give you an idea of what it is, basically. So let's say I have this index right here, right, and I have 5 shards. Oh, sure, yeah, you could go ahead.
We have a pen here. Oh, we did. All right. So what happens is you have your cluster here. You have data nodes, and you have masters. So if you have 2 masters, and now all these nodes talk to each other. Now, if you have a complete network divide where both of them think the other one is dead,
turn it.
not very well with the banner there. I cannot turn it. Not without moving the banner. I have to move the banner, Jerry. Yeah, it's going.
I can.
There it is. All right. So you have a complete network. I'll move this over for the moment. All right. So you have a complete network segment. So what happens over here is you have your clients here hitting the nodes. And both of them are persisting data. They both write the same ID. It will then persist that ID, and they will both think that they have the up-to-date version. So to resolve this, you have to either get rid of one of these sides, and I'm not sure of any other way to actually get resolution without killing these nodes.
Right.
Yes.
So the idea is you don't get in the situation
Yes.
to begin with. You create quorums, basically. So you always have more than half. There's settings available that say, make sure more than half of the nodes are available, and that will be my cluster.
Yeah, so if you add another one here, another node here that's master eligible, when they vote, when they vote, you'll get a majority for one of them. Now, when this network segmentation happens, these two nodes cannot talk to a master. They only have one master, so they don't meet the minimum, and they will go offline automatically immediately. And when the network segmentation goes away, they will come rejoin the cluster and be able to serve. Does that make sense? Is there anything you want to add?
Yeah, so the only thing I want to add is a split brain. If you ever encounter a situation, that's a bad situation. So the best way to get out of it is to not even try to fix it. So what you want to do is whatever split off, and if that data you think is older than the other quorum, that data needs to go away. And if you lose data, then you have to restore or reindex from somewhere else. But if that data is fine, you have enough replicas, you can just blow the data away, have the nodes come back to the cluster, and automatically replication will take care of all of that stuff. So.
Yeah, you can back up the disk with these, put them in. You can, when you restore from file system, you can bring it up as a different index name, and you can see what the new data is. So if you timestamp all your data, you can figure out what data was added, and then you can manually resolve it or script resolve it with what's in the other side. All right.
I have a question on the backup.
Yeah.
So does it stop processing in order to create that snapshot, or does it keep streaming?
I'm pretty sure it's fully online during the snapshot.
Yeah, so everything is live while the snapshot process is happening. You can do whatever exactly you want on the index, or any of the indexes in the cluster.
So when does that index actually occur? When does that snapshot?
So the snapshot actually occurs right when you make that call.
Right.
Whatever is the state of your cluster is what gets snapshotted.
Okay.
So right after that, any changes that happen is not captured in that snapshot.
Okay.
But you can execute more snapshots in the future, and you can catch them all up if you wanted to.
Okay.
Do we have a plan of having something like archive logs? So in Oracle, you have these archive logs, right? Like you could restore a snapshot and then apply the archive logs to bring it to from T0 to T1. So your snapshot was at T0.
I think
you got a figure at T1.
I believe the snapshot API is additive. It only indexes the change, I believe.
I didn't quite understand the question.
So you had a snapshot at T0.
Okay.
Right? And say the cluster went down at T1.
Okay.
Right. If you restore at T0.
That's
right?
correct. Yes.
So you don't have a mechanism of restoring the delta between T0 and T1.
If you don't have a snapshot of it, you cannot restore anything that you have. You don't have a snapshot of.
So do we have anything in the plan to have something like that, which is you have an archive which you can like what Oracle does, right?
I'm not familiar, unfortunately, with that capability. But anyway, so you can have replication, which is live failover. So those are backup copies of your data that's live, right? But that doesn't stop anybody from going and deleting indexes. Then it doesn't matter. But still, replication takes care of that line. And you can do snapshots as many times as you want. You can have it scheduled if you want to, every day, every night, however you want to. Whatever tolerance you can, you can handle. And as long as you have a snapshot up to that point, you can restore whatever snapshot you have. So
you took about kind of incremental backup.
Yeah,
sure.
Right.
Yeah. So yeah. By the way, when you snapshot today and then changes are made, let's say 5 new documents come in, and you make another snapshot after that, the whole thing is not copied again. Whatever was the difference from the last time, that's the only thing that gets copied. So if that matters.
Yeah, that's.
There's a lot.
Yeah.
All right. Any other questions before I go on to the?
I guess I have one thing to add on to that. If you have 5 snapshots and you lose the third, do you also lose the first and the second then?
Losing a snapshot.
So are you saying if you do snapshot 5 times, and let's say you delete like somewhere in the middle?
Yeah.
And what is the question?
Do you lose just the information that was deleted, or do you lose everything before it?
No. So you think of a snap. The best way to think about it is a point-in-time view of your cluster.
Okay.
So point in time, a future point in time, a future point in time, and a future point in time. And you can delete any of these in between. Whatever the point-in-time view is, at the point you made that snapshot, you can fully restore that point in time. And how it's implemented under the scenes, it doesn't really matter, because what matters is there's pointers in there that kind of know, they're smart enough that if you delete something in the middle, but some other snapshots are still using those bits of information, then it doesn't really go away yet. So there's some logic that's implemented in there. But the best way to think about it is point-in-time view, point-in-time view, point-in-time view. Whatever was the point-in-time view when you made the snapshot, you can restore that at any point, regardless of what happened to the other snapshots.
All right. So I wanted to move on to talk about the advantage of nested and why the nested data model is important. So if I jump down. So the first thing I wanted to do was let's create an index called park maintenance. And we're assuming that there's some cost involved. Let me go down to the data model. So we have a park, and we're assuming there's some cost involved in trimming trees. And for some reason, like if a tree gets too big, it hasn't been trimmed in a while, then you're going to have different amounts of money you would have to pay in lawsuits, or et cetera. So we want to identify the risk. So we take the cost of a tree trimming, the name of the park, take the height of the tree, and the last time it was trimmed to figure out the risk. So first thing I'm going to do is create this index. So let me just jump up. And run through it multiple times, so there's deletes in there too. So the first thing I'm going to do is create this. I'm going to create my index. And then I'm going to add some data to it. So I'm going to use the bulk API. We can create index park maintenance. Type is park. ID is central. And then here I am actually I'm declaring the ID. I'm not using the auto-generated IDs. Just wanted to point that out. And then I have some data about the parks. So I'm going to drop this data in, and we can view it via the head tool. All right. So now if I jump over here, refresh. All right, I created 2 indexes. In this index, it's nested. In this index, it's not. So the first thing you're probably going to notice is I have 8 documents here. I only have 2 here. So don't I have different numbers of documents in Elasticsearch? So the answer is no. Both of these indexes have the same amount of documents. So both indexes have 2 documents. So then the question is, why so many documents at the top level if I only have 2? So when I jump into it, I declared these as nested. So each time I add one of these subdocuments, it creates another Lucene document under the covers. So for each one of these, I create a couple of Lucene documents. And that's why the numbers don't match up. So, but that allows me more power when I query. So I wanted to do a quick comparison to 3 different ways of querying. So let me just put my data real quick. All right, so the first index I want to query is my plain index without any nested at all. All right, now my query. This query is a little bit different than the last one I did. So I'm doing a query here. I'm saying there's a must. So a must I usually equate to an and. I'm going to do 2 range queries. First one I'm going to say the height is greater than 50 feet. So I want all trees greater than 50 feet that have been trimmed last before this timestamp. So this is going to tell me all of the trees that are at risk of having trouble. I do the request, and why do I get 2 documents? If I look at this, it says 2, and both of them, so the key digit here is the 3rd digit. So less than 8, or yeah, less than 8, so 7's less than 8. So this first one should come back. The second one, I have 9, which is not less than 8, 8, which is not less than 8. So this document should not have come back. But why did it come back? The reason is you have greater than 99, match the first if. I have less than 3138, so I match this, so the document ended up coming back. This is the frustration I had with Solar. To solve this, you have to index them together, and I'm not sure how to do a range when you do that. Now, on nested, the query looks a little bit different. So I have this extra section up here called nested. I provide the path into my document, so it's park.tree. The scoring mode, I'm going to say take the total of the nested queries. I'm then going to say my Boolean must, same exact 50 and 138. Same exact data in both of these indexes. And here I get 1 result. I should not, because the other tree, the other part did not match my result criteria. So, any questions on that before I go into how you can mess this up? All right. So the way to mess this up, if you're not careful, you can still shoot yourself in the foot with nested. If you drop the nested down a level and put the Boolean outside of the nested, it's going to issue these queries irrespective of the document. So this is going to search for greater than 50 in the park, and it's going to search for less than my timestamp. I search, and I forgot to put my index. You do get errors if you search nested on a non-nested index. And I get my 2 hits. The general rule I tell everybody is do not repeat your path if you're using nested documents. If you have your path repeated, you're probably doing something wrong. Any questions? All right, with that, that's all I had for today. Thank you for coming out. If anybody wants to present, we are looking for presenters and hosts for the next meetup.
Another thing was about the presentation and the
Yes, I'll make the slides available after the presentation. We'll take all my notes, all the queries. I'll make those available to the meetup group. I'll probably throw them on a blog and send a link, or I'll just email them directly. But they'll be available after the meetup next couple days. Anything you want to say about the video? Or we're videotaping tonight, and I believe that will be made available as well.
Yeah.
All right. Yeah.